It's a tough call, but I'll try my best. Okay, representing Singapore, I'm going to share some of the case studies that's actually been done here. I was lucky enough to be involved in, I just counted in total 6 zero and positive energy that has completed. So, but I have to choose one. So I'm going to choose one for today because I got limited time of like now 14 minutes left. Before that, I'll just do some presentation about where we are in Singapore when it comes to our goal of getting zero energy in terms of Singapore approach. So as you all have seen this slide before so many times, but for those who has not seen it before, we have 5 pillars: city in nature, energy reset, sustainable building, green economy, as well as resilient future. So I'm only going to talk about energy reset because that's where the topic of today is, which is going to be zero energy. So in our energy reset. So just to give some people who are not familiar in Singapore, where are we in terms of GreenMark? Personally, I have never been to Japan, so I can't say anything about or compare anything with Japan. But for this, in Singapore, the GreenMark certification is administered by BCA, which is our Building and Construction Authority. We came out with this GreenMark certification, as I think the previous speaker has actually mentioned. However, we have just launched a new certification, upgraded it, which we call GreenMark 2021. It was just recently added into it to integrate and to harmonize our goals together with UN SDG goals, as well as Singapore targets and goals. So just kind of briefly bring you up to speed to where we are. We are GreenMark certification compliance, which means all our buildings, like all our buildings that is going to be built has to comply to this minimum compliance, of which is rather aggressive, of 50% energy savings. That's where we are. And after we have done this minimum compliance, then you will go to all the standards and protocols. So we have, like most certification programs, you have the levels of which all the way up to platinum. But however, since that we have the GreenMark certification compliance meeting 50%, we do not have any more gold. So we came all the way up to Gold Plus, and then we jumped to Platinum. After that, we have another group, which is called Super Low Energy, Zero Energy, and Positive Energy. Okay, I think this term Super Low Energy is quite exclusive to Singapore usage when it comes to certification program. So how does Super Low Energy benchmark against the energy savings? Is 55%. So if you could see my slide, the difference is hardly much. It's basically compliance at 50%, and then you add another 5% to 55%. Before you can go to zero energy. The mantra here and the goal here is always about reduction. Easier said than done, but you need to reduce before you do anything else. So you have the reduction, and then you can proceed to your zero energy, and then you're permitted to go to zero energy. After which, then you can proceed further to go into positive energy. We do not have zero carbon certification, if anybody would like to ask me that. So carbon here means is embodied carbon. We do not have any certification for embodied carbon. Here we're only talking about operational. Okay, you can ask me any questions later. However, after you have gone through the super low energy, you will go into zero, where you can and permitted to use local renewable energy credits as your offset. Just a little bit of refresher. This is our targets where it comes to 80%. We have to green 80% of our buildings by 2030, our existing buildings. There's an incentive scheme tag with that as well. And 80% of new developments to be super low energy by 2030. 2030 is like 7 years from now. So it's just around the corner. Everybody is getting jitters, but I'm sure you remain positive, we'll get there with all of stakeholders' collaboration. 80% of improvement in energy efficiency for best-in-class buildings. I love this topic a lot more. Best-in-class buildings by 2030. A lot of people are scratching their head, turning grounds, working with universities, academia, research groups to get this going. Okay, so that's where we are. Okay, I will spend 9 minutes to go through this particular showcase. It is a positive energy building for a change. Like I said, personally, I've gone through DBS Zero, Singapore Discovery, Nee Soon South a lot, but I find that this is an industrial building. I chose this because it's a pharmaceutical. A lot of the information is a little bit embargoed, so I try my best to share. Is Takeda. Takeda is a pharmaceutical company, it's an industrial company. We have just finished it, I think, 4 months or 5 months ago. So we haven't cut the ribbon yet. Will soon be, I think, next month. So this building is a positive energy building. I'll tell you how I actually managed to get through this to positive. Besides the solar panel, when we actually designed this building, we noticed that there's a lot of design collaboration that needs to be done within the design team. I'm an engineer by training, so I didn't design the building. The architect was the one who actually designed it out. However, there's a lot of weight reduction in cooling load that we have. So which means that we actually pick almost every single thing in this particular building. Someone just now in the earlier discussion in the morning said, zero energy building is limited to 3-story or 4 or 5-story building. I just would like to do a small little correction that yes, I would say in countries where you have limited energy production, such as Singapore, where most of our energy is actually coming from LNG gas or 20% by solar panel by 2050. But don't constrain your mind, don't get that so fixated, because different countries have different contexts. The reason why I have to tell you that is because in other countries where you have other sources of renewable or clean energy, you can get zero energy. Reason why I'm saying like Cameroon, we use geothermal, and geothermal is clean energy and you can have 60-story. So don't wrap your mind to say that it's only up to 5. It's context and it's very country driven. I just have to make that clear when it comes to energy production. So for this one, yes, we use solar panels, but the main thing is reduction. Reduction was very, very difficult. So when we actually reduce this, we cut a lot of what we call that silent cooling loads. Silent cooling loads are things like, okay, less than a minute. Silent cooling loads are cooling loads that's embedded inside the specification of all the cooling system. So you need to re-look into that with a magnifying glass and try to cut that down so that everything is simultaneously reduced to get the end. The other thing that we have actually put is a hybrid cooling system. As you can see in the morning when the US presented to you the cooling system with the hybrid, which is basically the fan as well as cooling load reduction and temperature up to 27. So what we did here was something else quite adventurous. Actually, we have like 7 or 8 different cooling load strategy using the cooling strategy. What we have is that we blend into a parameters of control strategy that the fan will move from speed 1 to speed 3 depending on the thermal comfort, and the air side will be able to control it also depending on the Internet of Climate, which is the outside temperature. So we have all this little benchmarking. We took a lot of pain using a control system, a very good BMS system, to do this so that the user will reach a certain thermal comfort. Other strategies that we actually have, we have like 7. So what we did was that we packaged it in bundle 1, bundle 2, and bundle 3. So, and we compared bundle 1, 2, and 3 and see how it moves from bundle 1 to bundle 3. So sometimes you realize the movement is only 0.05%. So you drop that because it doesn't make sense. So you move with the bundles. It's a little bit like Lego stack. You move the bundle, which gives you the best value in terms of financials, economics, but also the best value in terms of life cycle and operating costs. And you complete that particular exercise. So over here, bundle 3 was not so good. As you can see, I like figures. So at the end of the day, we chose the best bundle that could actually meet it. And this is operation building, which means it's finished. Okay, it's not design stage already. This is finished. So that's how we actually got through the award of positive energy. So of course, it's my last chart. I just want to tell you the waterfall chart. So we use a lot of waterfall charts to see how much progressive reduction in energy that was actually embedded. Few of the green features, which I cannot share here, would be reflective film, but it's not your ordinary reflective film that we actually put it down here. Another one is the control strategy. The best part about this building is that we didn't use chiller. I mean, it's one of the very few positive energy building that we didn't use water cool. We only use air cool chiller. And we use aeroton fans, a fans that will be able to control the amount of velocity that is coming out. So the lesson that we kind of like learn in this is that integration is super, super important and verification is super important. The reason is I'm more worried about post zero energy than getting to zero energy most of my time. Because once the building is performing, and then when the occupant comes in, that's when you are at risk on many certain situations. Like people are not happy about the environment, so they said we wanted it to be cold. So that particular mitigation will actually put a lot of threats onto maintaining zero energy coming up for the future, or coming up for positive energy in terms of the future. The other thing that I also noticed is in terms of solar panel generations. Here, we didn't use BAPV, building attached photovoltaic or building integrated. Here, we purely use bifacial solars. And so with bifacial solars, we managed to get 15% more for the same space. So I'm all about stretching the value for what we actually have over a period of 10 times, 10 more years. Because in 10 more years, I still want to maintain this building to be a positive energy. I'm very adamant about that. So I need to preempt a lot of possibility that might go wrong. And that preempt, you have to work with the user of the building. Otherwise, you will never strike that same chord. So I'll share out this slide for everybody to reflect on. Thank you.